Nuri, a space launch vehicle built entirely with domestic technology, recently launched into space and successfully made it into a standard orbit. 13 years after the launch of Naro in 2009, it is the first successful launch and entry into orbit using only domestic technology. After the United States, Russia, Germany, China, India, and Japan, Korea has now emerged as one of the top 7 space powers. Let's learn this time about Nuri's launch technology and the scientific technological capacity for its entry into orbit. Nuri. The mission of Nuri was to put a satellite in orbit 700 kilometers above the Earth. Nuri consisted of a total of 3 stages of rockets, and the first stage rocket, which combined for 75-ton engines, was equipped with a liquid-propelled rocket engine. The 300-ton thrust created by this engine easily lifted the 200-ton Nuri with the law of action and reaction. A massive amount of flames are ejected from the 4 exhaust nozzles, which are attached like a funnel at the very end of the first stage rocket, generating a pushing force. Then, a force of the same magnitude acts to push up Nuri. With this power, Nuri overcame gravity to fly up and separated the first stage rocket 2 minutes after launch, followed by separating the second and third stage rockets. 15 minutes after launch, it reached the target orbit at the altitude of 700 kilometers. The engine made with pure domestic technology. Made with pure Korean technology. The center of Nuri is a liquid-propelled rocket engine that uses liquid fuel kerosene and liquid oxygen as an oxidizer, a substance that gives oxygen. These 2 fuel elements in this rocket's combustion chamber mix to create an explosive reaction, generating tremendous flames and formidable power. But why do we need liquid oxygen? Oxygen is necessary to burn matter because there is no oxygen in space. But a flame of 3,300 degrees is twice as hot as 1,500 degrees of a smelting furnace that melts iron. The rocket engine doesn't melt because of the regenerative cooling system. The tube inside the unit contains very cold fuel or oxidizer, which circles and cools the combustion chamber and the nozzles. The significant challenge of placing an application satellite in the desired target orbit falls to Nuri. An object floating in space that is caught by gravity and keeps circling at a specific height is referred to as being in orbit. This orbit allows a satellite to continue orbiting for the entire length of its life without refueling. A rocket launched into the sky changes its direction to enter orbit at the target point. At this time, an inertial guidance system is necessary to indicate how much the rocket deviated from the original point, calculates the angle away from the initial position and gives the direction, and the rocket corrects the path with the calculated angle. Small rockets attached to the main rocket slightly change the direction when in orbit,